I'm really excited about this question. This is a funky probability question. The other probability question I have is actually a 6 marker, which is really, really rare to have in GCSE. This one's only 5 marks, but boy, is it a funky question. It was really poorly answered. It's absolutely terrifying, but let's have a look. So we have there are R red counters and G green counters in a bag. Counters taken at random. The probability it's green is 3/7. So the first thing I'm thinking is, how do I use that information? Well, how do I work out the probability of getting a green counter? Well, we take the number of green counters over the total number of counters. I don't know that in this case, but I know it's going to be R plus G, right? The number of reds plus the number of greens should give me 3/7. That gets you a mark already, by the way, just so you know. So straight away we have an equation. But the next part is where it gets interesting. So there are 2 more red counters and 3 more green counters to put in the bag. A counter is taken at random, and the probability is now 6/13. So again, how do I get the probability of green? Well, first of all, how many greens do we have? Well, we have G. Add 3, because there are 3 more green counters added. And the total it's still R plus G, but we're also adding on 2 and 3. There are 5 more counters that have been added. So I'm going to do plus 5 equals 6/13. And the goal of this question is to work out the number of red and green counters in the bag originally. So basically we're trying to work out what R is and what G is. Okay. Looks fun, right? I mean, wow. What a question. So this is actually simultaneous equations, and it's a simultaneous equation you can only solve by substitution. And so essentially what we're going to do is we're going to rearrange this equation to get an equation for either G or R. I think I'm going to do G just because G's on the numerator. That's literally my entire reasoning there. You could also rearrange for R if you want to. It's up to you. Sub it into this equation. The reason for that is at the moment we have 2 unknowns in both of our equations. And if you have 2 unknowns and 2 equations, it means you can always solve it using simultaneous equations. We can't use elimination because it just isn't set up in that way, but we can use substitution, because when we sub in, let's say if we get G equals 5R and I sub that into here, all of a sudden I only have 1 unknown in that equation, so it's solvable. So let's do that. How do I know I'm rearranging this equation? Because this one just looks a hell of a lot harder. Technically you could rearrange this equation and sub it into here and you will get an answer, but this one just seems a bit easier. So hopefully that answers my problem solving strategy there. Hopefully that answers any questions you have. So again, I chose this equation because this one looks easier to rearrange. So I'm going to times both sides by R plus G. We get G is equal to 3/7R plus 3/7G. Then I'm just going to subtract that to the other side. So I get 1 whole, right, because there's a 1 in front of here. Take away 3/7, so that leaves me with 4/7 of G equals 3/7R. We can cancel out the 7s, divide both sides by 4, and that is probably a lot quicker than it would have been otherwise. And I'm going to sub that in to this equation. Would it be easier to sub in for R instead? Maybe. It might be quicker to do that, but let's do this this way because it really doesn't make a difference in the sense of your answer anyway. So you get 3/4 of R plus 3 over, we still have R plus 3/4 of R plus 5 equals 6/13. Now we can combine those 2 R's on the bottom, so we have 3/4 of R plus 3 over, that would be 7/4, 7/4. Once again, I'm going to times this up to the top. I could cross multiply if I wanted to. In fact, I'm going to cross multiply just to get rid of the fractions because I'm allergic to fractions. 13 times 3/4, well, 3 times 13 is 39, so it's 39/4. It's always interesting, whenever I do this question, I always do a different method slightly. So, interesting. 3 times 13 again is 39, equals 6 times 7/4, well, 6 times 7 is 42. And 6 times 5 is 30. Cool. So it looks like I want to move the R's to the right hand side to make it not negative. So I'm going to subtract 39/4R from both sides. I'm going to do this in a few steps, even though you could technically do this a bit faster than what I'm doing. equals 3/4 of r plus 30. Subtract 30 from both sides, so we get 9 is equal to 3/4 of r. Times both sides by 4, you get 36 equals 3r. So that means r is equal to 12. And then g is 3/4 of r. So if g is equal to 3/4 of 12, so 12 divided by 4 is 3, times 3 is 9. That's how many counters we had originally. Again, a super interesting question. It's simultaneous equations, but it's not really the style that we teach that much in GCSE, but it is technically a simultaneous equation. Remember, if you have two equations with the same two unknowns that are true at the same time, they must be simultaneous equations, and so you can solve them by elimination or substitution. In this case, substitution was about 10 times easier. So yeah, very interesting in my opinion.